Hi, please take out your chemistry notebooks and get ready to take some notes as you watch this video. Once you have your chemistry notebook out, please title your notes for today, Valence Electrons and the Periodic Table.
We're going to talk a lot about electrons. First, we're going to start out looking at an atom and looking at the spaces in an atom where electrons can live. Then we'll learn about the most important type of electrons in an atom. These are called the valence electrons. We'll learn how you can figure out how many valence electrons an atom has by looking at where that atom is on the periodic table. And finally, we'll look at how you can take an atom and draw one of these electron dot diagrams for it that shows how many electrons it has. So let's get started. Okay, so check out this diagram of an atom I have here. In the middle is the nucleus with protons and neutrons. And now look at all of these little circles. Each one of these circles represents a spot that could hold one electron. You can think of these as like parking spots for electrons, or like theater seats for electrons. And these spots for electrons are organized into these circles. These circles are called energy levels or shells. You can think of these energy levels or shells sort of like they show the path that the electrons would take as they're spinning around the nucleus here. But also, energy levels or shells arrange electrons into different groups that are varying distances from the center of the atom.
Okay, please add this to your notes. Energy levels. When we are drawing atoms, we draw energy levels as circles around the nucleus that show the path the electrons move in. Energy levels are also how electrons are arranged into groups at different distances from the nucleus.
So for this first group, this first energy level or shell can hold 2 electrons, really close to the nucleus. Moving out a little bit, we get to another shell that can hold 8 electrons, and they're spinning out here. And then even further out, we have another group that can hold 8 electrons. Now it keeps going from here, and there are more and more energy levels or shells. But it gets a little bit tricky, so I just wanted to focus on these first 3 to give you an idea of how they work.
Please add this to your notes. There are a maximum of 2 electrons in the first energy level of any atom. There are a maximum of 8 electrons in any other energy level of an atom.
Now, if you've learned a little bit about atoms already, you might know that the way I've drawn this here, this isn't the most perfectly accurate way to represent electrons and atoms. But you know what? It doesn't matter. For our purposes right now, we just want to learn the basics. Drawing and thinking about atoms like this is totally fine. So don't worry that it's not super accurate. Okay, so let's look at what happens when we start filling these electron parking spaces, when we start filling them with actual electrons. So we're going to use the periodic table for this. We'll go column by column. And here's what I'm doing. I've made this big version of a periodic table, and you can see it looks a little bit different than the real version of a periodic table, okay? Look at this whole thing in the middle. This is sort of a big, real periodic table. We're not going to worry about any of these elements in here in the middle. So this whole section, I've put it here, just gotten rid of it. We're not going to worry about it. We're only going to focus on 8 columns. We're going to focus on these 2 right here, which I've drawn there, skipping everything in the middle, and then we're going to focus on these 6 over here. So don't get confused by the way I've drawn this. We're just leaving out some of the elements that we don't want to get into right now. Okay, so let's take the first element right here, hydrogen. Now, how many electrons are there in hydrogen? Okay, well, what we got to do is we got to look it up on the periodic table, and we're going to find something like this. Now, the periodic table, it doesn't actually tell us how many electrons are in hydrogen. It's got this 1 here, but that refers to the number of protons. So there's 1 proton in hydrogen. That's what its atomic number is. Now, if we assume, though, that this hydrogen atom, if we assume that it doesn't have a charge, then the number of electrons is going to equal the number of protons. So hydrogen always has one proton, but if the atom is neutral, if it doesn't have a charge, it will also have one electron. So let's go back to this diagram of the atom here. Let's just start with this first energy level. Okay, here's a drawing just of the first energy level. Let's put a nucleus in here. I'm not actually going to draw the protons and neutrons. Instead, I'm just going to write the number of protons. Okay, so this has one proton, and P plus is the abbreviation for proton. So one P plus in the nucleus. Now here are the two spots in this first energy level where electrons can live. There is one electron in hydrogen, so we're going to fill that in. That was really easy, right? So we got this first energy level in hydrogen. One of the spots is still empty, and one of the spots is full.
Please add to your notes a Bohr model of hydrogen. So first of all, there will be one proton in hydrogen. There is one electron. Since these are neutral atoms, if there's one proton, there's one electron in an atom of hydrogen. Now let's draw that Bohr model. Our nucleus has one proton, and our first energy level has one electron.
Okay, let's move down here to lithium. Now if we look up lithium on the periodic table, we're going to see this 3, which means that every lithium atom has 3 protons in it. But if that lithium atom is neutral, which we always assume that it is when we're doing this sort of thing, this lithium atom also has 3 electrons. So we'll start here. We'll be first concerned with this, this energy level that's right here, the first one here. I'm going to put a nucleus in here, P plus, because there are 3 protons in here. Okay, so there are 3 electrons. So this one is going to get filled, and this one is going to get filled. And now we're going to want to go to the next energy level. Okay, now that starts getting filled. So now it's going to look like this. Now we want to start thinking about the second energy level. The first one is filled, and now one electron is going to go here in the second energy level. Okay?
Let's add a Bohr model of lithium to our notes. So lithium atoms have 3 protons, and because they're neutral, they also have 3 electrons. Our Bohr model will then have 2 electrons in the first energy level and 1 electron in the second energy level. And we show the electrons by coloring in the circles.
So these energy levels, they're really like parking spaces. Imagine that the nucleus is a mall, right? It's like the parking spaces closest to the entrance of the mall, those are the ones that fill up first. And then as more and more people park, the empty parking spaces move further and further and further away from the center of the mall. It's exactly the same way with atoms, okay? The first energy levels close to the nucleus, those are the ones that are going to fill up. And then, after they're full, the other energy levels further out, they're going to begin to fill up too, okay?
Let's add this to our notes. How do energy levels fill with electrons? Well, it's kind of like a parking lot. The spaces closest to the nucleus get filled with electrons first. And then after the energy levels closest fill up, electrons start to fill the next energy level.
Now, let's look at sodium. Sodium has 11 protons in its nucleus, 11 P plus, and we're going to assume that since it's neutral, we're assuming that it's neutral, it has the same number of electrons as protons. So let's start filling them in. 1, 2 in the first energy level. Now that's full, so we're going to start filling the second energy level. 3, 4, 5, 6, 7, 8, 9, 10. And finally, these are all full, but we still have more electrons, so now we're going to have to bump it to the third energy level. Here's a third energy level that we can start filling in. 10 of these are already living in the atom, so we're going to add one more. And now there's 1 in this third energy level.
Let's add the Bohr model of sodium to our notes. Sodium has 11 protons. And because it's a neutral atom, it will also have 11 electrons. So let's now draw that Bohr model.
Okay, now check this out because this is important. hydrogen, lithium, and sodium, they all have different numbers of electrons. But there's a pattern here. Check this out. Each one of these atoms has one electron in the outermost shell. Okay? This one's full, but then there's just one here. This one's full, and then there's just one here. And then hydrogen here only has one energy level, and it just has one electron in it. These electrons, 1, 1, and 1, these are the valence electrons, the most important electrons in an atom. We'll talk more about that later, why they're so important. But all you have to know for right now is that the valence electrons are the electrons in the energy level that is the furthest out from the nucleus. So in this atom, the valence energy level is the third, and it has one electron. And here, the valence energy level, the furthest out, is the second. And here, the furthest out, the valence energy level, is the first. So there's a pattern. Each one of these atoms has one valence electron. That's true, not just for these first 3 atoms, but for every one of the atoms that's in this first column in the periodic table. I didn't want to do the electron structures for all of these others, but just trust me that they all have one electron.
Valence electrons are the most important electrons in an atom. These are the electrons that are in the energy level furthest from the nucleus. Elements in the same group on the periodic table, the same like vertical up and down group, will have the same number of valence electrons.